Let's take a look at section 9.1 on points, lines, planes, and angles. And in chapter 9 you'll see that we are working with geometry. And so in this section we're dealing with a fair number of items: points, lines, planes, and angles. And we'll begin with actually lines. The reason we're starting with lines rather than points is that basically a point is something that we all understand what we're talking about. This would be a point. See if I can get my pen to write. There we go. And it turns out Euclid tried to define a point as, let's see, that which has no part. So that doesn't make a whole lot of sense. So to me it's easier just to draw a point and say, there we're talking about a point. Now, from points we move up to lines. A line extends infinitely far in two directions, and we're going to have 2 points on this line, A and B, and we're going to put little arrowheads on the end to indicate that it goes infinitely far in both directions. The symbol we would use for indicating the name of this line is AB with a line over top of it, or BA with a line over top of it. So our symbol looks very much like our drawing. Now a half line, AB, and here we have our point A. In this case A is not included, but B is. This would be half line AB. It goes up to A but doesn't include A. And our symbol here over top would be the same. Half line BA, we'd have the open circle on B, include the point A, and our arrow would go in the other direction. Now when we write the name, we always write the open-ended part, the open circle part first. Okay, now ray differs from a half line in that the end point is included. So we'd have ray AB, and the symbol would have the little ray on top of it. Ray BA would start at B, go through A, and continue on. So there's ray BA's symbol. And finally, line segment AB. We have both endpoints included. And notice we could call this segment AB or segment BA. They both give us the same item. Okay, parallel lines are lines in the same plane that do not meet. Skew lines are lines in different planes that do not meet. So it's a difference between parallel lines are in the same plane, skew lines are in different planes. So they're out in space. Angles, an angle is the union of two rays that share a common endpoint. So this would be an example of an angle. Let's call that A. So that would be angle BAC, or we could call that angle CAB. Okay, so that's what we mean by an angle. An acute angle is an angle that measures less than 90 degrees. Remember, a 90-degree angle we sometimes call a right angle, okay? An acute angle is one that's less than 90. A right angle measures exactly 90. An obtuse angle measures between 90 and 180, so here's an example of an obtuse angle. Okay, a straight angle okay, that would be an example of a straight angle. It's just a straight line, measures 180. Complementary angles are two angles that add, I'm going to highlight complementary is 90. whereas supplementary angles add to 180. 180. Okay, so a lot of terminology in this first section. All right, let's see how we can do on the exercises. Angle ABC measures 160 degrees. What kind of angle is angle ABC? Okay, we talked about acute, we talked about right, we talked about obtuse, and we talked about the straight angle. So, which one is 160 degrees? Okay, and if you're saying obtuse, that's correct. What is the measure of the supplement of angle ABC? If it's measuring 160 degrees. Supplementary angles we know add to 180, so that would mean we would need a 20-degree angle as a supplement. Angle CDE measures 35 degrees. What kind of angle is angle CDE? Okay, so that one would be acute. It's less than 90 degrees. What is the measure of the complement of angle CDE? Well, we know complementary angles add to 90, so that would be, let's see, what do we need? 55 to get to 90 degrees. All right, angle RST measures 180 degrees. What kind of angle is angle RST? It's going to be a straight angle. Angle XYZ measures 90 degrees. What kind of angle is XYZ? That would be the right angle. And I'm hoping you remember these from high school geometry, that it should be part of your common knowledge at this point. Find X and then find the measurement of the two angles in the diagram below. Okay. Alright, suppose, and I'm just making these up as I go along, suppose this is our drawing. We see that we have a right angle, so that means the measure of the sum of the two angles that are shown there should be 90 degrees. So we're going to create an algebraic equation. The bigger angle plus the smaller angle should give us 90 degrees. So if we add these up, we get 4x plus 10 equals 90. And I'm going to subtract 10 from both sides. So I get 4x equals 80. Divide by 4. X is 20. So I'm asked to find the measures of the two angles in the diagram. So this one would be 20 degrees. That means my other one is going to be 60 plus 10 would be 70 degrees. And I usually put my answers in the drawing to make sure that I'm ending up with something that makes sense. Alright, find X and then find the measures of the two angles in the diagram below. Alright, let's draw another picture. Let's say this is x plus 5 and 2x plus 10. Okay, so this time as I look at my two angles, I see I have a straight angle. So the sum of the two should be, that's correct, 180 degrees. Alright, so I now have 3x plus 15 equals 180. And I'm going to subtract 15 from both sides. Moving up here. So I get 3x equals 165. Okay. And divide by 3. What do we get for x? 55 degrees. Okay, so this would be 60 degrees, and this one would be 120. Oops. And this would be 110 plus 10 is 120. Okay, yeah, that makes sense. So these are my two answers. Okay, and we have another one very similar to what we had before. And I don't think I mentioned vertical angles, so let's do something with vertical angles. Okay, this diagram creates two angles that are two pairs of what we call vertical angles. Okay, so if I call this angle 1, 2, 3, and 4, 1 and 3 are vertical angles, and 2 and 4 are vertical angles. So, let's say this angle is x plus 10, and this angle is 5x plus 20. Okay, so what do we know would be true? We know 5x plus 20 equals x plus 10. So 4x up, we'd have to have a negative number. That's not going to do it. Let me steal a number here from the book rather than pulling something out of my head, which probably won't work again. All right, let's try 5x minus 129. 5x minus 129 and 2x minus 21. Okay, now these should work out better. 5x minus 129, that's what I didn't do. I didn't make them negative. Okay, so if we get our x's together, we can subtract 2x from both sides. We get 3x, and I'm going to add 129 to both sides. So that's going to give me, I believe 108. Divide by 3, and we get x is 36 degrees. So if we take 2 times 36, 2 times 36 minus 21, it's going to give us 51 degrees. We should get the same thing on the other side, so I'm going to check that with my calculator. Yep, we do get 51 degrees. So both angles are 51 degrees. I guess that's basically enough on those. So now, the last thing we have is we're